Good morning, students. Subject electronics device and circuits. So, from the chapter number 4, oscillators, we have seen the following points. So, very first we have seen what is the oscillator. So, in that oscillator versus the amplifier we have seen. Then we have seen alternative versus oscillator. Then we have seen the classifications of oscillator. In that sinusoidal oscillator, non-sinusoidal oscillator. In that non-sinusoidal oscillators also means we have considered only the sinusoidal oscillator. Then in nature of sinusoidal oscillator, damped oscillations and undamped oscillations we have seen. Then we have seen the Barkhausen criteria for the oscillatory circuit. So what is the Barkhausen criteria? That is nothing but the product of amplifier and the feedback factor should be 1. That is the Barkhausen criteria of oscillator. Then let us see the types of the oscillator. So for this chapter we are going to see the 5 types of the oscillators. So phase shift oscillator, Wien bridge oscillator, tubed oscillator circuit, crystal oscillator, unijunction oscillator. So let us see the one by one oscillators. Or because we have seen what is mean by oscillator as well as which type of the oscillators and which type of the oscillation is produced by the oscillator. So let us see the phase shift oscillator. So here RC phase shift oscillator. So that is resistor capacitor phase shift oscillator. So what is the principle behind that the phase shift oscillator? So here voltage is applied of the circuitry which having only the capacitor and resistor value. So according to that it will develop the voltage out and the output across the load resistance area. So we know that the output voltage of an RC circuit for a sine wave input leaves the input voltage. Okay, we know that output voltage of an RC circuit for a sine wave input leaves the input voltage. So, the phase angle by which it leaves is determined by the value of RC component used in the circuit. So, the following circuit diagram shows a single section of an RC network. Okay. So, the output voltage V1 across the resistor R leads the input voltage applied input V1 by some phase angle phi theta. If R were reduced to 0, V1 dash will lead the V1 by 90 degree, that is phi is nothing but the 90 degree. So however, adjusting R to 0 would be impracticable because it would lead to no voltage across R. So therefore, in practice, R is varied to such a value that makes V1 to lead V1 by 60 degrees. So the following circuit diagram shows the 3 sections of the RC network. So what is the summary of this session? Principle of the phase shift oscillator, what it says? That we know that output voltage of an RC circuit for a sine wave input leads to input voltage. The phase angle by which it leads is determined by the value of RC component used in the circuit. So the following circuit diagram shows a single section of an RC network. So the output voltage V1 across the resistor R leads the input voltage applied input V1 by some phase angle phi theta. If R were reduced to 0, V1 dash will lead the V1 by 90 degree, that is phi is equal to 90 degree. However, adjusting R to 0 would be impracticable because It would lead to no voltage across R. Therefore, in practice, R is varied to such a value that makes V1 dash to lead V1 by 60 degrees. So let us see the following RC network. So here three RC networks are connected with each other. So each section produces phase shift of 60 degrees. Consequently, the total phase shift of 180 degree is produced. So that is voltage V2 leads the voltage V1 by 180 degree. Okay. So here each RC phase shift produces 60 degree phase shift. So total 180 degree phase shift. So phase shift oscillator circuit that produces a sine wave using a phase shift network is called as phase shift oscillator circuit. So the constructional details and the operation of the phase shift oscillator circuit are as given below. So let us see the construction details. The phase shift oscillator circuit consists of a single transistor amplifier section and a RC phase shift network. So the phase shift network in this circuit consists of three RC sections. So at the resonant frequency F0, the phase shift in each RC section is 6 degrees, so that the total phase shift produced by RC network is 180 degrees. Okay, so in phase shift circuit, single transistor amplifier section is used and three RC sections are used. So each section will phase shift 60 degree. So the whole the network is 180 degree phase shift. So let us see the following circuit diagram shows arrangement of RC phase shift oscillator. So this is nothing but the circuit arrangement of phase shift oscillator. So here that is FUT is used as a transistor. So gate, drain and source terminal. So at the feedback, so means feedback is connected to the from the output side to the input side. So from that the output, that is the drain terminal, the output is taken common and fed to that input side. So this is the oscillator circuitry. So very previously at the starting of this chapter we have seen the block diagram. So for that oscillator block there are only two inputs. One is the DC phase shift, DC power supply, and another is that the output side. So here the output is taken as a common to the input side. So here this is the RC network, second and third. And here bypass capacitor is used across the source terminal. This is the transconductance of the FET, and this is the frequency response from this oscillator. So it will produce the frequency, that is F is equal to 1 upon 2 pi root of 6 into R. So according to resistance and capacitor value, we can set the frequency of the phase shift oscillator. Why it is known as the phase shift oscillator? Because it will produce the phase shift between the input and output. So that's why it is known as the phase shift oscillator. So the frequency of oscillation is given by F naught is equal to 1 upon 2 pi RC into root C. So where R1, R2, R3 is equal to R, that is the same value, and C1 into C3 equal to also C, that is also the same value for the capacitor. So let us see the operation of the oscillator. The circuit when switched on oscillates at the resonant frequency f0. Okay? The circuit when switched on oscillates at the resonant frequency f0. The output E0 of the amplifier is fed back to the RC feedback network. So this network produces a phase shift of 180 degree and a voltage here appears at its output. So this voltage is applied to the transistor amplifier. So the feedback applied will be M is equal to ER divided by E0. So the feedback is in the correct phase, whereas the transistor amplifier, which is there is common drain configuration, common source configuration, produces a 180 degree phase shift. The phase shift produced by the network and the transistor act to form a phase shift around the entire loop, which is 360 degrees. Okay? So the phase shift produced by the network and the transistor add to form a phase shift around the entire loop, which is 360 degrees. Means from this side to this side 180 degree. Again here we have applied. It is input network is 180 degree. So what are the advantages of this RC phase shift oscillator? The advantages of RC phase shift oscillator are as follows. It does not require transformer or inductor. It can be used to produce a very low frequency. The circuit provides good frequency stability. Okay, so what are the advantages of the RC phase shift oscillator? It does not require transformer or inductor. That is the main thing. Then it can be used to produce very low frequencies. So the circuit provides good frequency stability. So these are nothing but the advantage of RC phase shift oscillator. Then what are the disadvantages? The disadvantages of RC oscillator are as follows. Starting oscillation is difficult as the feedback is small. What is the drawback of RC phase shift oscillator? Starting oscillation is difficult as the feedback is small. The output produced is small. The output produced is also small. So let us see the operation in detail. A phase shift oscillator consists of a single stage of amplifier. That amplifies the input signal and produces a phase shift of 180 degree, the input and its output signal. Okay, so a phase shift oscillator consists of single stage of amplifier that amplifies the input signal and produces a phase shift or 180 degree the input and its output signal. So if a part of this output is taken and fed to the input, so if a part of this output is taken and fed back to the input, it results in negative feedback, causing the output voltage to decrease. But we require positive feedback, which means that the voltage, so signal feedback should be in phase with the input signal. What we have seen, if a part of this output is taken and fed back to the input, it results in negative feedback, causing the output voltage to decrease. But we require positive feedback, which means that the voltage. So the signal feedback should be in phase with the input signal. So the output of the amplifier should take on through a phase shift network to provide it an additional phase shift of 180 degrees. So the amplifier provides a phase shift of 180 degree and the phase shift network also gives a 180 degree, and therefore a total phase shift of 360 degree results, and therefore a total phase shift of 360 degree, which is equivalent to 0 degree phase pulse. So the RC network provides the required phase shift by using 3 RC. Okay, so the RC network provide the required phase shift by using 3 RC. So each having some value of R and C. These values are selected so as to produce 60 degree phase shift per section. So resulting in total of 180 degree phase shift as desired. But in actual practice, each RC section does not provide the same phase shift because each section loads the previous one, but the overall phase shift is 180 degree, which is the requirement. The output of the phase shift network is connected to the input of the amplifier. The frequency at which phase shift is 180 degree is this is the frequency of oscillation. So at this frequency 129, for loop gain A to be greater than 180, gain of the amplifier stage must be greater than 29. So A is greater than 1. So when we calculate the A greater than 29. So here each having some values R and C. So these values are selected so as to produce 60 degree phase shift per section. So resulting in total of 180 degree phase shift as desired. But in actual practice, each RC section does not provide the same phase shift because each section loads the previous one, but the overall phase shift is 180 degree, which is the requirement. So the output of the phase shift network is connected to the input of the amplifier. So the frequency at which phase shift is 180 degree, this is the frequency of oscillation. So at this frequency, 1 of the 29 for loop gain A to be greater than 90. So gain of amplifier stage must be greater than 29. So A is greater than 29. So another type of popular audio frequency oscillator is the Madhuri oscillator. So that we are going to see in the next section. But now we have seen the phase shift oscillator, so which contains the resistance and capacitance. So which is, if suppose which is having the three stages of RC, so it will produce 60 degree, 60 degree, 60 degree. That is overall 180 degree phase shift. So we can say that Amplifier provides a phase shift of 180 degree and the phase shift network also produces 180 degree and therefore the total phase shift is 360 degree or we can say equivalent to 0 degree. Okay, so we have learned here RC phase shift oscillator. Thank you.